Enhanced Interior Gateway Routing Protocol. Once upon a time, it was Cisco's proprietary EIGRP routing protocol, designed and proposed by Cisco. But now it is open for everyone. EIGRP, Enhanced Interior Gateway Routing Protocol. It's a very old protocol because the older version is IGRP. So EIGRP is an enhanced version. So EIGRP is newer. It's the another version of IGRP which is old. Yeah, IGRP is truly old. IGRP and EIGRP, the difference is classful. I remember I told you this in CCNA. IGRP is classful. EIGRP is classless. IGRP don't support VLSM, whereas EIGRP does support. We're going to go in depth. So this chapter is going to teach us EIGRP fundamentals, how the path metric calculation is done, how the failure is detected, and also the timers, and then the route summarization. Right, in the fundamentals, we're going to see how two routers form neighbor. And then after forming neighbor, how they exchange the route updates among them. In the path metric calculation section, we are going to see how the advertised distance and the lowest feasible distance contributes in identifying the best path, which is also a loop-free path. So not only the primary path, even the backup path also checked thoroughly so that there won't be a loop. We call it as feasibility condition. And in the failure detection and timer, we are going to see how quickly EIGRP can use the topology table to converge whenever there is a change in the topology. And whenever a neighbor goes down, how long it takes for a neighbor to be removed from the neighboring table, etc. About the route summarization is good. Earlier version of EIGRP, we saw auto summarization is enabled by default. That's why we used to say no auto summary to cancel it. Whereas in this new version of EIGRP, which we are going to see, summarization is off by default. So summarization won't be done by default. Routes are going to be sent in detail without any summarization. Only we need to do summarization wherever is needed. So we can enable summarization globally as well as interface level. Interface level summarization, we call it as manual summarization. Yeah, EIGRP supports two types of summarization. One is manual summarization, which is done under the interface. The other one is the global summarization, which is enabling auto summary. EIGRP fundamentals. EIGRP can do even unequal cost load balancing, which is really a unique feature in EIGRP. So load balancing is not possible when the metrics are different for different paths to the destination. All protocols by default supports only low cost path and equal cost. If you want to do load balancing, equal cost load balancing is by default available. But unequal cost load balancing, only EIGRP can support. For this, we need to configure variance. Unequal cost load balancing, though it is supported, it is not enabled by default. We need to enable it by tuning variance. Unequal cost load balancing is supported when you tune, when you enable, when you configure variance. We will be seeing these things in lab in coming days. The number of hop count, the number of hops from where you can learn route in EIGRP domain is 255. You can learn routes from any hop between 1 to 255. The default is 100, but you can say max hop 255. That's the maximum. Learning route from 255, 254, 253. So any number of hops between 1 to 255. Because it is maintaining a backup path, because EIGRP maintains a backup path in the topology table, when the primary path goes down, immediately it makes the backup path as primary, and packet will start using this new primary path. That's why we can experience a rapid convergence here. Fast convergence, rapid convergence. Now we saw that EIGRP selects the best path as well as the alternate path by making sure that there is no loop. It is possible through this algorithm called diffusing update algorithm, dual. Diffusing update algorithm. This algorithm is to pick best path and give it to the routing table, and also the second best path, which is a feasible successor route, to be kept as a backup path in the topology table. Right. Okay. See, EIGRP's metric is not hop count. Metric of EIGRP is slowest link bandwidth plus sum of delay. That is what used in the algorithm in route selection. It's not hop count. Though the maximum hop supported is 255, hop count is not a metric. Now EIGRP works in group. It's not like a RIP protocol. RIP protocol never forms group. EIGRP forms group. EIGRP will form neighbor only with the group member. For example, here, router 1, router 2, router 3 and 4, they belong to one common group called 100 autonomous system 100. Likewise, 5, 6, and 3 is common group called 200. From this picture, what do you learn? Router 3 is a part of two EIGRP. One is EIGRP 100, another one is EIGRP 200. Will R1 ping R6? No. Will R6 ping R5? Yes. Will R6 ping R2? No. Because they belong to two different autonomous systems. The route of autonomous system 100 will not be given to autonomous system 200 by R3. Even though R3 has got knowledge of R6 as well as R2, R3 will not take the routes of this autonomous system and give it to the other autonomous system. It won't give. It will not give. Whatever it learns from this link, it will give here. It will not give here. It won't give. But in the routing table of R3, you will find routes from R1, R2, R3, R4, sorry, R5. Yeah, R4 is also. I'm already in R3, so R6. This will have routes of both the autonomous system. Actually, you are running two EIGRP here. EIGRP 200 is running only on this two link. It's 100 here. So this picture teaches us that you can run multiple EIGRP in a single router. We can run multiple EIGRP in a single router. Each EIGRP will be independent. Each EIGRP is identified with an autonomous system number. That is the common routing domain. So between these four, there is common routing domain. Between these three, another routing domain common. That is what autonomous system means. Autonomous system is group of router with common routing domain. We have two routing domains here, EIGRP 100, EIGRP 200. Routers within the same domain uses same metric calculation formula, and they exchange routes only with the members of same autonomous system. Only. Very important, underline. Only. Some terminologies in EIGRP that we should know in this fundamental EIGRP class. What is a successor route and what is successor? If you take router 1 here, there are multiple paths to go to router 4. This is one path. This is another path. This is another path. This is another path. There are 4 paths. Now, which one will be the successor path? You see, you should see the total metric. It is 256 and 256. 256 is 512. Whereas here it is too costly, 2,560. This is also very costly. This is okay. Now you need to calculate cost like this. From here to here, which is 256 plus 256 plus 2816. That's the total cost from R1 to R4. Via this way, it is 2560 plus 2816. Okay, now what is a successor route? The route which has got the lowest feasible distance, lowest total metric, lowest path metric to reach this destination. This is the lowest. Do you see any other lowest? I don't see any other lowest. The lowest feasible distance. What is feasible distance? The total distance from here to the end. That is called feasible distance. The lowest feasible distance is the successor route. So for R1 to reach this network in R4, the successor route is via R3 and R4. Then what is a successor word means? The immediate hop. If this is the path, R3 is the successor. In order to reach this network, who is the successor? This is the best exit. This is the best next hop. This is the best gateway to reach this network. The best gateway is what called a successor. See, for a network here, let's say you have a network here. For that also, this is the best gateway. R3 is the successor because this is too costly. R2 is not a successor. The best exit. Okay. Now, we have learned successor route and successor. Now we are going to another confusing term, feasible distance and reported distance or advertised distance. Reported distance is also called as advertised distance. Both are same. So I want to repeat this successor route and successor. Successor route is the elected route. The route with the lowest metric is the elected route. What is successor? To use the elected route, the next router, the immediate gateway, the exit interface is the successor. The best exit has got a gateway, the very next router. The very next router via the best exit is the successor route. Now, what is feasible distance? Feasible distance is the metric value via the successor route to reach the destination. Feasible distance is nothing but the total metric via the best path. We just saw that the successor route is via R3. The metric via successor route to reach the final destination is what the feasible successor means. which is 256 plus another 256 plus 2816. Now, what is the reported distance or advertised distance? The metric from the successor to the final destination. We learned in the previous page that R3 is a successor. Now, what is advertised distance or reported distance? The metric from the next hop to the final destination, which is 256 plus 2816. What is the value? என் பொண்ணா இருந்தா என்ன டக்குன்னு சொல்லிட்டு இருப்பா, அபேகஸ் படிச்சு எவ்வளோ டக்குன்னு சொல்றாங்க. எவ்வளோ பெரிய நம்பரா இருந்தாலும் இந்த வயசுல ஃபர்ஸ்ட் ஸ்டாண்டர்ட் தான் டக்குன்னு கூடி சொல்லிடுறாங்க. நமக்கு அந்த காலத்துல சொல்லி கொடுக்காதனால இப்படிலாம் போட்டு செய்ய வேண்டியதா இருக்கு. படிக்கும் போது இவ்வளவு கஷ்டப்பட்டோம். படிக்கும் போது கஷ்டமா தான் இருக்கும். அப்புறம் தான் அதனுடைய பலன் தெரியும். See, it is 3074. Successor to the final destination is the advertised distance or reported distance. Reported distance is the distance from your successor now. The distance reported by the router, this is the router that is advertising this prefix. This router 3 says, in order to reach that destination, for me, metric is 307472. That is what it is advertising. What will R4 advertise? It will say, for me, it is 2816. What will R2 advertise? For me, it is 2560 plus 2816. So what do you see here? The next hop to the final destination, that metric is what called as reported distance or advertised distance. The reported distance value is the feasible distance for the advertising router. Number. Feasible distance. What is feasible distance? We saw that feasible distance is the total distance, total metric via the best path. For R1, this is the best path, that is feasible distance. For R3, which is the best path? For R3, this is the best path. So R3's feasible distance is what? Reported distance for R1. R3 is feasible distance. That's why here it is written. Reported distance value is the feasible distance for whom? For the advertising router. For the advertising router, that is the feasible distance. For example, R3 advertises 10 for 4 with this. R4 advertises 10 for 4 to R1 and R2. I told you this will advertise 2816. This will advertise 2816 plus 246. All right. So advertised distance is the metric of the next router to reach the final destination. Okay, now, do you have any confusion in this page and in this page? Okay, let me stop this page for a minute. You see, this is a very important place. The reason is many are not clear with this. Feasibility successor. The previous pages, there was only talking about successor only. Successor route, and then uh, feasible distance and reported distance. But now we are seeing feasibility successor. There is no feasibility successor discussed anywhere before. So if you are clear with these four things, successor route, successor, feasible distance and reported distance, then you will not have confusion when I talk about feasibility successor and feasibility condition. Feasibility successor may be a confusing term for you, but you know, if I write this, you will understand this better. The path which is elected to be a backup path, the path which is elected as a genuine backup path is feasibility successor, a genuine backup path. All path cannot be a genuine or acceptable backup path. You see, if you take flight from Bangalore, 4 hours if you go this way, okay, this way. If you go 4 hours this way, you will go to Middle East, Dubai or somewhere. Now, what can be a backup path? Backup path is going 4.5 hours and coming down to Dubai. This place is Qatar, Doha. This can be a backup path. If this path has got some issue, you can go like this and come. You can also go to Dubai like this. Go straight to Amsterdam. From Amsterdam, come down to Lagos, Africa. From Africa, go to Egypt, Addis Ababa. From Addis Ababa, you can come to Dubai. Will you accept this as a backup path? Ayo Sami, that is what he will say. Ala udrapa. எவ்வளோ நேரம் நான் ஃப்ளைட்டில் உட்காந்துருக்கேன். Though that is a backup path, that is not considered to be a backup path. உலகத்தையே சுத்திட்டு வரணும் backup path எடுத்துக்க முடியாது. Though you can reach Dubai that way, that won't be considered accepted as a backup path. Why this is accepted as a backup path? Because it met the feasibility condition. Because this path is accepted, because this path is meeting the feasibility condition, this has become a feasible successor, feasibility successor. Why this is not elected as a backup path? It didn't meet the feasibility condition. That's enough feasibility condition. Number பேசின the discussion that we had. In that discussion, we are talking about hours. 4 hours is the actual time. If 4.5 hours, it is okay. That is what feasibility condition. It is okay plus or minus 30 minutes. But when you take this path, you will be at least 32 hours in the flight. 32 hours from Bangalore to Dubai. 32 hours to take this route. cannot be considered as a backup path. Now let us read. What is feasibility condition? See, this is already a primary path. Will be there in the routing table as well as in this router's routing table will have to go to 10.4.4.4 R3 as a next hop. It will be also seen in the topology table. This is the successor. Yeah, that is the successor. Now this is for electing a backup path. This is to understand how a backup path, a feasibility successor is elected. How a feasibility successor is elected. For that, the backup path should be qualified, should meet the feasibility condition. Condition is this: the advertised distance or the reported distance received must be less than the feasible distance calculated locally. Please understand. Via router 3. What is the total metric you know? 2816 plus 256 plus 256. This is 512. I'll write it as 512. So 8, 2, 3. So going via router 3, it is 3328. 3328 is what called as successor value. Successor value. We saw here the successor root metric, the low path metric. The successor root metric is what? The feasible distance. The successor value. That is what this one, feasible distance calculated locally. Feasible distance is nothing but what? The total distance from local to the destination on the best path. 3328. Now what does it say? If this need to be a qualified backup path, the advertised distance or the reported distance, what it is reporting, 2816, should be less than, see I'm drawing what it is saying, less than the feasible distance calculated locally. True, no? This is true. That is why this is called as feasible successor. The condition is this: the reported distance should be less than the successor value, should be less than the feasible distance on the successor route. That is what I call it a successor value. Successor roots metric or successor value. Did you understand this? The argument is, will this path be a backup path or not? For that, what it is advertising, Means the router once next stop is R4 via this path. For R4 to reach the destination, what is the metric? 2816. That is what R4 will advertise. That value should be less than 256 plus 256 plus 2816. If this is true, only then this can become a backup path, which is also called as feasible successor. You understood? This router 2 will not be a backup path. You know why? The reported distance by router 2 is 2560 plus 2816. This one and this one, which will be more than 5000. But it should be less than this total value. This total value, some 3000 change we got. This is more than 5000. So this cannot be a alternate path. It won't be seen in the topology table. You understood? Topology table. EIGRP contains a topology table that makes it different from a true distance vector routing protocol. That is true. You see, the distance vector routing protocol, they don't really maintain topology table, but EIGRP does. That is why EIGRP is an advanced distance vector routing protocol. EIGRP topology table is a part of dual algorithm and helps to identify a loop-free backup route. It contains all the network prefixes advertised within EIGRP autonomous system. We have seen many times the topology table. What you see is you will see all the prefixes of that autonomous system learned from other neighbors, and also the primary and the backup path, successor and the feasibility successor route. So what do we have in the topology table? We'll have networks, means various destination networks, and the neighbor via which you learned it. What will be the metric via each neighbor? It will have both reported distance as well as the feasible distance. And then that's all. I don't know from where they got this one. This won't be there. We will see what it. We will see when we go to the topology. The last point is what we usually, it calculates using bandwidth and delay only. Oh, here it is. Listen. Correct. I don't know where they got that point. You see, for each destination, it shows the neighbor via which you learned. Via this neighbor, this is the total distance. Via this neighbor, this is the total distance. We can call it a successor value or feasible distance. And there are two feasible distance. The lowest feasible distance is the successor value. This route only will be seen in the routing table, not this one. This is only a backup route. Will be seen only in the topology table. And this is the reported distance. This is the metric of the neighbor. That's all you will see in and also the exit interface. That's all you will see here in the topology table. I don't know from where they got this point. Values used to calculate the metric. Funny. You see, they say a table contain values used to calculate what? Where it is? This is composite value. There is no value called bandwidth and delay and load here. So, or composite value means bandwidth and delay. That is what you see here. And in this, P means good, passive. Passive means it's a settled, well settled route. You should not have active. Active means it is searching for a path. So topology table shows successor and the feasible successor. See, this is the successor because this has got lowest FD. This is not a feasible successor. Sorry, this is not a successor. This is only a feasible successor. Feasible successor is the backup path. In the routing table, you will find only the successor. In the routing table, we will not see feasible successor. These are the 5 messages that are shared between the EIGRP running routers. First message is hello message, which is sent every 10 seconds to 224.009 address. This will discover neighbor, and also if a neighbor go down, it will know that neighbor is no longer available when the hello packet stops coming. Every 10 seconds every 5 seconds they must send the hello packet, and the 15 second the neighbor is considered no longer available if hello don't come for 15 seconds. Now the request is sent whenever there is a query. Whenever there is no backup path, you have only one primary path, but that also gone down. Immediately the request will be sent to other neighbors querying for the lost route. And if any router knows the path, it will give an update. Request is what query? Query is sent to many neighbors. That is what we call as request. See, query is searching for another path. To whom it will search? By sending a request to one or more neighbors. Query and request is connected, interconnected. Update and reply is also interconnected. Response to the query is what? Reply. Response to the request is what? Update. Right? So, in this first topic of EIGRP fundamentals, we learned that it's a distance vector protocol, but it maintains a topology table and it supports 255 hops. So we call it as advanced distance vector routing protocol. It uses an algorithm called diffusing update algorithm, which is responsible for picking up the best path and also a backup path, which is low free. EIGRP works in groups. We call it as autonomous system. Autonomous system is nothing but a routing domain. Routes from one routing domain will not be given to another routing domain. If you wish to do that, you can redistribute, which we'll see later. And then we saw that successor route is nothing but the route which is having low metric to reach the destination. The successor is the immediate router via the best path. Feasible distance is the total distance from the local router to the final destination. Reported distance is the distance from the next hop, which is a successor to the final destination. Feasibility condition is advertised distance of the alternate path. Advertised distance can also be called as what? Reported distance. The reported distance of the alternate path should be less than the successor route's feasible distance. If the condition is met, only then the path can be taken as a feasible successor, which is also called as backup path. In the topology table, you will have all the prefixes in the autonomous system and their neighbor router which advertises them the route information along with the feasible distance slash reported distance via each neighbor. And this is how it will look like. And then we have 5 different type of messages here, which is shared between the neighbors. Hello is sent every 5 seconds. Request or query is sent whenever there is a need for some information. An update is a response comes from a neighbor which knows the answer to the query. Query and request are same, update and reply are same. Right? We'll stop here.